So they give us the graph of f of x, which from the activities we did, we should recognize which one is this? The reciprocal one. So we do know the actual equation for this. We know that this red graph's actual equation, that's its explicit equation, is y equals 1 over x. So we'll do some work with that. But they're assuming you don't know what the graph is, so they just called it f of x. And they told us the transformations of f of x in function notation. And I'll show you what this question looks like at the end if they gave it to you as an explicit equation. The first thing I'm going to get you to do with the function notation is if the 4 is with the y, move it over to the other side so you have things working from left to right. Then we'll just do a quick labeling of what is happening. The first thing we run into is the half. What will that be? Vertical or horizontal? Horizontal. Translation or stretch or compression? Stretch. Horizontal stretch, because you would multiply x by 2. Next thing we run into is the plus 1. Still inside the function. That'll be a horizontal translation. It'll move it 1 to the left. And notice it's already factored. Maybe we'll just put a little star here. Because I noticed that right away, but I didn't say anything. And sometimes when a math teacher notices things and doesn't say it, that means that you don't notice it. Right? Always check if it's in that factored form. That's why we wrote that special note. Because if you start doing your work and it isn't in that factored form, you're going to make a mistake in your translation. You won't even notice it. And finally, we've got a vertical translation there. So it's important that it's already in factored form. We moved the 4 over so that we could work from left to right. And for a reciprocal graph, what we're going to do is we're going to just look at these 2 points and these 2 asymptotes. So I'm going to label my original asymptotes on here. Y equals 0 and x equals 0. And for a reciprocal graph, the only points that you have to work with are the 1, I'll do them in red here because they're on the original graph, 1, 1, and negative 1, 1. We'll also look at what happens to the original asymptotes of x equals 0 and y equals 0. So going from left to right, we'll run into our stretches and compressions first. We only have one stretch. That's a horizontal stretch. That will make x by 2. And I'll leave the asymptotes at the end here. Let's just do our points. If I would do x by 2, yep.
Would the second point be negative 1, negative?
Yes, it would. Just forgot the negative there. Thank you. So we're going to multiply our x by 2. That will change this one to 2, 1, and this one to negative 2, negative 1. And then the horizontal translation, the vertical translation, you can do those at the same time with the arrow because the horizontal one will mean that we're going to go left 1 unit and down 4 units. And since one affects the x and the other affects the y, you can do that at the same time. If I go left 1, I'll go to 1. If I go down 4, I'll go to negative 3. If I go left 1, I'll be at negative 3. And if I go down 4, I'll be at negative 5. Lots of places for easy mental math errors. So take your time when you're doing these points. And after each one, just do a quick check to make sure that you're mental math was right. Because you'd hate to make a little mistake in one of the arrows and then later on have a tough time finding out where you made that mistake. Now the only thing that affects asymptotes, can you see if the x-coordinate is 0, it doesn't matter what you multiply it by. It'll always stay 0. Same thing with the y-coordinate. So you can ignore the x by 2 in this case, because that's not going to affect the asymptote. What will affect the asymptote is moving things left or right or up or down. So in this case, when I move it left 1, my new asymptote will become x equals negative 1. And when I move it down 4, my new asymptote will be y equals negative 4. For this one, I think it makes sense to graph our new one on a separate graph so it doesn't get complicated. If you have one of those little graph papers, you can stick it into your notes, or you can just draw a set of axes. X equals negative 1, start with that asymptote and label it. And y equals negative 4. Would look like that. Our final graph, we'll label our points. We've got 1, negative 3 right there, and negative 3, negative 5, and since we know that your reciprocal graph goes towards the asymptotes, you'll just draw the correct shape going towards the asymptotes. And for a reciprocal graph, you would only have to look at those 2 points, unless the question specifically said label 3 points. But this would be what you would need to label. Those 2 points, you would need to label your asymptotes. You need to make sure you have arrowheads on the end of your graphs. And that would be our final graph. So this is how this question looks if it's function notation. If this was a little bit harder question, the original graph wouldn't be given to you, and they would write it in explicit notation. So I'll just write the same question. The question would look like this. It would say graph y equals, and we've got 1 over 1/2 x plus 1 minus 4. And this, I think, when it's written this way, would be a much harder question. First of all, you would have to say, where's my x and what's happening to it? And when you look at this equation, you say, okay, my x is here in the denominator. It's in the bottom of a fraction. Is that connected to any of the graphs that I know? And then you would connect it to this graph. And since you connect it to that graph, the first thing you would do is draw the y equals 1 over x graph, which was done for us up here. But you would have to know that's the shape of my graph. These are my asymptotes at y equals 0 and x equals 0. The points that I know are at 1, 1 and negative 1, 1. Okay, so you would have to know that graph. Then you would have to say, how is my black graph here changed from my original graph? One of the things you would say, where is my x on my original graph? It's on the bottom of the fraction. What's on the bottom of the fraction now? That. So whatever's on the bottom where the x was is inside the function. Wherever the x was is what we consider inside the function. So you would say, oh, this is a horizontal stretch by 2, and 1 left. Then this minus 4 is outside of the function. That's going to move it down 4. The vertical stretch, if there was one, would be in front. I'll draw it in blue here even though it's not there originally. Could be a 3 right in front. But how do you multiply fractions? You might sometimes see that 3 instead of the 1. And then that would be hard to kind of like, okay, that 3 got multiplied by that 1, so you've got to sort of have some sort of algebraic manipulations. So I'll just... So yeah, this would be a harder question, especially with the reciprocal, because I find that one's the hardest to see what's inside the function, just because it looks a little bit different than normal. Questions you can do for this one? Slurpee.